Hello, today we're going to learn Chapter 1 in Intermediate Algebra class. Now, in any first chapter of a math class, it seems kind of scattered. It seems like we're learning all kinds of weird different little things, but we're trying to build all of these little pieces up to the bigger picture in our later chapters. So just kind of stick with it, and even though it seems a little all over the place, you're just gathering all your pieces. So the first thing is we're just going to talk about the numbers themselves. So in any number, you know that the whole number part, the ones you're more familiar with, go out to the left and they get increasingly larger in their place value. And then of course the decimal point separates the decimal part. And you notice that these look pretty much the same as their counterparts on the left, except for the TH at the end. So we have tenths, hundredths, thousandths, but also just note that there's no oneths place. So it's kind of one off from what you might expect. So just keep that in mind. And we use this knowledge in our rounding. And remember that in rounding, 5 and above will round up, and then 4 and below will round down. So just like at the store, if you didn't have exact change or something, in this time where we can't get our coins back, we would hope that they give us the closest dollar amount. So we see where they're going to round here. So let's try it out with some of these examples here. And we're just going to round to pretty much every possible place value. So in this first number here, if I were asked to round it to the 10,000th place, this first number right here, actually let's even start one bigger. If I wanted to round this to the hundredths place, the 100,000th place. So that would be right here. Well, actually there's not 100,000 in it just yet. It's a 0 over here beside the 6. But if I did want to round it to that 100,000th place, then I would have 100,000. Because it is closer to 100,000 than it is to 0. So let's just label these. Let's letter them A, B, C, D, E, F, G, H, I, J, K, L, and M. So this was rounding to the 100,000ths, which would be B. Next, we're going to round it to the 10,000th place, C. So that would be right here. This is my 10,000th place. So I always look at his neighbor. In this case, his neighbor is the 8. So 8 is, of course, 5 or above, so that would bump him up to the next number, which would be a 7. So this rounded to the 10,000th place would be 70,000. So notice after the place that I have indicated, I wanted 10,000ths, everything past that was a 0. So I don't put 78,000, that would be silly. 68 was closer to 70,000 than it was to 60,000. So this one right here, like I was saying, the 0 right here, we looked at his neighbor, the 6. The 6 was 5 or above, which is why it rounded the 0 up to a 1. Now, if I wanted to do the thousands place, the 6 is the 10,000ths. I'm going to look at the thousands, which is right here where the 8 is. So his neighbor is a 2. That is 4 or below. That means he's going to stay an 8. He's not going to round up. And then everything past the place that I indicated was a 0. Now note that you would never round down. You would never go from 68,000 and some change to 67,000. That would be silly. You had more than 68,000. So the options were either 68,000 or 69,000. And we saw that it was closer to 68,000 than it was to 69,000. Okay. Next, let's do the hundreds place. So the 6 and the 8 are going to stay put. It's the hundreds right here. The 2 is in question. So we look at that 2 and we look at his neighbor, the 5, and we see that that's the 5 or above. So from a 2, we round up to a 3. Our options were 68,200 or 68,300. We were slightly closer to the 300. If I wanted to round this to the tens place, I would get 6, 8, and 2 all the same. My tens place right here by the 5 would look at his neighbor, the 1, his neighbor to the right, and that means that 51 is closer to 50 than he is to 60. So we would stay right there. And then last, if I did want to round it to the ones place, it seems a little silly because it's already in the ones place. So no rounding would need to be done. He would stay 68,251. That's pretty much every way you could round this number. So whole numbers are a little more familiar with most people. Let's try it with a decimal. So again, we're going to keep this same lettering here, and we're going to do every possible rounding. So I'm going to start with the biggest one, which is right next to him here, this 0, which would be in the hundreds place. So the hundreds was letter E. I'm going to start it on letter E. So if I wanted to round this to the hundreds place, I'd look at his neighbor, the 2 in the tens place, and that is a smaller number. It's 4 below. So if I wanted to round this to the hundreds place, I would actually have 0. He's closer to 0 than he is to a full 100. Next, if I wanted the tens place, that's the 2 right here. His neighbor of 1 is small, so he would round to the number 20. Notice I don't put 20.0000 because that implies that you have rounded it out to those 4 decimal places. It indicates that there's more precision than you meant. You have rounded it. You only know that it's around 20. Putting decimals implies more knowledge than you have. So be careful not to put those zeros there. You stop it at the decimal point. So G, if I wanted to round it to the ones place, this guy right here is my ones place. His neighbor to the right is a 6, which is in fact higher than 5, so he would round up to 22. He is closer to 22 than he is to 21, and I would never round down. Now you might say this one I rounded down, this one I rounded to the tens place. I would never round down to 10 as opposed to 20. Okay, next I would do the tenths place. That's right here. Remember, there's no ones place. So his neighbor, the 2, says that he's going to stay a 6, not round up. So I would get 21.6, and then I'd stop. I wouldn't put any more zeros. I only put the zeros up here because that's what helped me know that this was not the number 683. It was 68,300. Also notice that as I went down the line, I didn't start over, I did start over. I didn't reference the number before it. So like this one right here was 250 and this was 251. I didn't look back at this one. So what I mean is if you're rounding multiple times, always look back at the original. Don't round your 22 the wrong way because you were looking at this, not the original number. Okay, I is the hundredths place. So the second place past the decimal right here. And luckily his neighbor is a 0, so that's easy. So rounded to the hundredths place would just be 21.62 and stop. Don't put those zeros. It's incorrect if you put the zeros. If you wanted the thousandths place, then I would say it's 21.620. That's the thousandths place. His neighbor is a 0, so we would just stop right there. It's been rounded. And then one more, if I did want the 10,000ths place, then I would put the full number. But putting any zeros past this 2 indicates more precision than you have. It has been rounded. Okay, let's try it again with this number. We have some special cases that get tricky with the 9s especially. So again, let's just start the biggest we can with the hundreds place. So in this case, the hundreds place, which we had the letter E, would actually have a more interesting answer because the neighbor to the 100, the tens place, is 5 or above. 85.3249 is closer to 100 than it is to 0. So I would round it up to 100. If I wanted to round it to the tens place, like I was saying, I don't look at this, okay, I look at the original. The tens place is the 8, his neighbor is a 5, which would round him up to 90. He's closer to 90 than he is to 80, just a little. Okay, next if I wanted the ones place, the ones place is right here. His neighbor of 3 would not round up, so he would stay 85. The tenths place would be the 3, his neighbor's the 2, so that would be 85.3, would not round up. If I wanted the hundredths place, the 2 here has a neighbor of 4, and this is the sneaky one. That's why I put this example. His neighbor of 4 only. Don't look past the 4. 4 is less than 5, so he would stay a 2. He would not round up. So it would be 85.32. And here's why I kept mentioning not to reference. The last one, if I did want to round to the 10,000s place, then I would say 85, sorry, that would be the thousands place. Then his neighbor of 9 would round this 4 up to a 5. So I would get 3, 2, 5. But that does not influence this guy, even though the rounded 5 right here would make this number round differently. The original number was 49. 49 cents is closer to $0 than it is to $1 full dollar, just a little bit. So let's try the same on these and notice that it's almost the same number, it's just those tricky 9s. So on this one, if I wanted, let's just start at the ones place. The ones place, which was G. Then this neighbor of 3 would keep him at 65. If I wanted to round it to the tens place, his neighbor of 2 would keep him at a 3, 65.3. Here's where it starts to get interesting. Those 9s are involved. So if I wanted the hundreds place, his neighbor of 9 would of course round him to another 3, 65.33. Okay, so this almost identical number, let's try it again. He would round the same for the ones place, and the same for the tenths place, and the same for the hundredths place. Let's see what happens after that. If I did want to round it to the thousands place right here, this is my thousands, this 9, and of course his neighbor of 9 would round him up. But what is up from 9? Well, it's 10. So 10 bumps into the next decimal place. So in this one, I would say that this 9 turned into a 10, carrying that one over, turn this rounded number into 65.330. Now this 0 is important because this was for the thousands place. If it's rounded to the thousands place, I need the thousands place. So I put the 0 here on purpose because it was rounded to a 0. It just happened to be the number 0. So let's try it one more time. So this same story is going to start out the same rounding for the whole, same rounding for the tenths, same rounding for the hundredths, and that's where it starts to get interesting. So next the thousands, just like the one before it, here's my thousands place, the 9 would round him up, which would bump the next place value, 9 goes to 10, so that would be 65.330, just like the last problem. And we see that for the 10,000s place, we have the same scenario. So this 9 right here would be rounded up again, which rounded up from 9 would be 10. And then this 10 would turn that one into a 10. So rounded to the 10,000s place would be 65.3300. And again, I would need the zeros this time because I rounded it to the 10,000s place. Putting zeros on a rounded answer like this would indicate that it had been rounded to the 10,000s place when it had not. This was rounded to the tenths place. So just be careful. Only add zeros when they're important. So if you were asked to round to the 10,000s place, then you need a 10,000s place. Next, we're going to look at classifying numbers. So it's not so much that we're going to have a vocabulary test, but it's good to understand what the numbers are because they react in different ways. So in this class, we will exclusively deal with real numbers. The only alternative to real numbers are the imaginary numbers that you'll look at when you get to college algebra. The real numbers break down into either rational or irrational, but they're easy to distinguish because the irrational numbers are the weirdos. They are very distinct. They're weird. They're going to be things like uneven square roots, pi, or the irrational number e. Yeah, I did say number. It is a number e. It's weird. So they're very weird. Uneven square roots and pi and e. So rational numbers can be fractions, they can be decimals that go on forever in a repeating pattern. So the weirdos are only decimals that never end and never repeat, which is what these guys do here. So everything else is rational. Most of the time we deal with rational numbers. Now those rational numbers may or may not be integers. Integers is just the fancy name for a number that doesn't have a fraction or decimal part. It's these cleaner numbers here. Now non-integers don't really get a fancy name. Either they're integers or they're not. Now those integers may or may not be whole numbers. Now whole numbers, I write it funny like this, are all of the numbers from 0 and up. They are non-negatives. They're integers that are not negative. So the negatives, again, don't get a special name. But if they are 0 or up, then they are considered part of the whole numbers. And then the only other classification are the natural numbers. And the only difference between whole and natural is the number 0. So the natural numbers are the ones where you naturally start counting. So if I made some dots up here, you would start counting 1, 2, 3, starting at 1. So let's classify these numbers right here. So we already know that they're all going to be real. All of these are real. And then next we know that they will either be rational or irrational. It's an either or, they have to be one or the other. So remember the irrational numbers, they're special, they're weird. So most of these are going to be rational. I'm going to abbreviate. This guy right here, he's our weird one. So he is irrational. Okay, next of the rational numbers, we're going to see if they might be integers. The irrational numbers, I know I'm done. If it's irrational, it's nothing else. So these that were rational, let's see if it's an integer. Remember, integers don't have a decimal or fraction part. So he's got a decimal, he's done. He does not have a decimal, so he is an integer. And I abbreviate. He does not have a decimal, so he is an integer. He's done. He does not have a decimal, he is an integer. Now the ones that are integers, I'm going to keep looking to see if they may be whole numbers. He wasn't an integer, so he is now done. Can't do anything else. So is he a whole number? Remember, just non-negatives. He's got a negative, so he's done. Well, he's not negative, so he must be a whole number. He's done. This one does not have a negative, so he's a whole number. Now of the ones that are whole numbers, let's see if they're natural. Oh, this is 0. I couldn't naturally start counting to 0, so he's done. But this one is 3. Just like we did with the dots, we could naturally count to 3, so he is a natural number. Okay. Now, all of the real numbers appear on the number line. They may be in between the slots, but they're there somewhere. So if I wanted to plot some dots on the number line, I would look along the line for some indicators. So if I wanted like the -1 here, here he is right here. Make a nice pretty dot for -1. If I wanted the number 4, here he is right here. If I wanted 6 or -5 or -2, I can find them, where of course the negatives are on the left and the positives are on the right. And that's standard, that's always the way they're going to be. Now these other guys, we're going to have to be a little more careful. -4.5. So be careful, I would go to the -4 from 0, 1, 2, 3, 4, and an additional half step. So it's halfway between -4 and -5. Okay, be careful, this would be 3.5. This is past the -4. This one is +3.5. So if I wanted +3.5, I would go to the right 3 steps, 1, 2, 3, and another half. Now this one's a fraction, but don't worry, we got this. If we weren't sure how to represent this, we could find it in our calculator as a decimal. We would see that he's actually -3.5. That means I would count from 0 to the left, 1, 2, 3 steps, and another half. I could have also counted by halves. So I could have counted -7 halves. So I could have counted to the left 7 halves. 1, 2, 3, 4, 5, 6, oh, hang on, from 0, sorry. 1, 2, 3, 4, 5, 6, 7. And I see again that I end up right there at -3.5. Now in this case, we were just plotting specific numbers. We found all of those. We're going to put a tail on that red one, didn't mean to. On this next one, we're going to be plotting a group of numbers. So if I wanted to plot all of the positive integers greater than 5, well, remember, integers are the specific ones without decimals or fractions. So it's just going to be distinct dots on the integers. All of the ones greater than 5. So here's my 5. If they're greater than 5, I'm going to go this way. But what about 5 itself? Is 5 greater than 5? He is not. So I start at the 6. 6 is the first integer greater than 5. Now is 10 the last one? Of course not. 11 is also greater than 5. So I would keep going. So we would indicate that these continue on for the rest of infinity. Now what about the integers less than 3? Now if I just wanted integers less than 3, I'd start back over here because -8 is an integer and it is less than 3. But this asked me to find all of the positive integers. So positive, that means I would start in on the right side of the number line. Now again, 3 itself is tricky, but 3 is not less than 3, so I go down to 2. 2 is the first number less than 3. So I look here, and then 0. 0 is also sneaky. He is an integer, he is less than 3, but 0 is special in that he is neither positive nor negative. So I would actually only have these 2 dots for positive integers less than 3. 0 is not positive, these are not positive, and then in between is not integers. So that would be all of our dots. So next we're going to just go through some calculations, and I want to show you some of the calculator tricks. The main thing is the difference between the minus on the side, the operation of subtraction, and then the little negative down here on the bottom. Most of the time you want to subtract, you want to use the operation. It's this little guy that we're going to use whenever we're using negative numbers, especially if we start out with a negative like in this first example here. So if I wanted to make my very first number to be a negative, if you start by hitting the negative button on the side, you actually see that it says A and S. And it's because it's trying to subtract from the previous answer that it has on its screen. In my case, it's this weird decimal. So if I typed in -5, it thinks I mean that answer -5, and it gives me this crazy thing. What I really wanted it to do was to take the opposite of the positive value 5. So I use the little negative on the bottom and then the 5. So I do -5 like that, and then I see it look more normal on the screen. Now I could type it in just like it is here and do plus and parentheses and -10, but simplify this in your mind. So a lot of times I get asked the question, what's the difference between negative and subtract and minus and all of these things? It's all the same. It all means that it's on the left-hand side of the number line. You owe money in the bank, stuff like that. So in this problem, when you're adding a negative value, you're really just subtracting. This problem is really a -5 that went down 10 more. So that means on the number line, you would have been starting at the -5 and you would have continued to move left 10 units. So typing that into your calculator, just like I rewrote on the screen there, -5 minus 10 says that the value is going to be -15, which would make sense. If you borrowed another $10, now you owe $15. Now I get some crazy decimals in, but this one's written nicely. I don't have any extra random symbols, so I'm going to go through and figure this up just typing straight into the calculator. 4.9 minus 2.67 plus 13.934. And I get the decimal 16.164. Now write the whole thing out. Unless it specifies that you should round, write the whole thing out. Sometimes I'll get people write 16.16 and they just got lazy or something. And then you get counted wrong when you just needed to write one more number on the paper. So if it does not say to round, don't round, write the whole thing. This one's got some extra symbols. Let's see if we can clean it up some. Minus a minus. Well, it's really saying to take the opposite of a negative. So if you subtract a negative, it becomes a positive. So this was really the number minus 15 plus 5. And then if you add a negative, adding a negative balance into your bank is really subtracting. You're going down in balance. So the only time it switches to a positive is this double negative, where the two minuses are together side by side with no numbers in between. So like this problem right here is not a double negative. This is $9, withdraw another $5. This is minus 14, not positive. And the best example I could come up with to make this make sense in my brain was like if I found a $5 charge on my credit card. I'm looking through my statement and I'm like, I didn't make that. So I call my credit card and I say, hey, can you reverse this $5 charge? And they say, sure. And then they add the $5 back into my account. So it's the reversal of a negative. So that's why it happens. After you get it cleaned up a little bit, I always recommend doing that first. If you try to type these symbols, it's way too easy to mess something up. Then you can type it in, and you could see that this would give you a negative 10 balance minus another 10 would make a negative $20 balance. And then be careful, it was tempting that these would cancel because they matched. But if you owe $10 and borrow another 10, you're not clear, you now owe 20. So whether it's written horizontally like this or vertically like this, you can still work it in the calculator. Just always keep an eye out for those double negatives. So this one you can actually type in just like that, minus 20 plus 26, and then hit enter and it should give you the answer of 6. You could type this in very carefully with the negatives, but it's so much easier if you just rewrite it as the minus 3 plus 9. Here's that double negative, no numbers between them, minus the charge. So that would give you a value of the same 6. Now this one right here, I've got some numbers plus the minus is really just minus. So I would type in minus 48 plus 22 minus 51. Don't put plus a minus. It gives me a negative 77. And then last, this big string of numbers, I'm just going to type them straight in. Minus 50, make sure to use the little minus on the bottom for the very front number. And then minus 35 with the side, minus a key, minus 15 plus 82. Gives us an overall value of negative 18. Okay, so just kind of, oh, hang on, a couple more here. Here's some of those double negatives. Remember that those are going to turn into the positives, so this would really be minus 6 plus 8. Accidentally skipped these easier ones. That's okay, we've got them now. And then this one right here, whenever it's written in Word, and we're going to talk about some of the words for, mathematical symbols more in this last section, but always keep an eye out for these two sneaky words, from and than. Those are the sneaky ones. They're the ones that make things be backwards. If I asked you to take 3 from 5, you would tell me that I would leave 2, because you know that I'm really asking you to take 5 minus 3. If I asked you, what is 3 less than 5? Same story, you tell me the answer is 2. Because even though I'm saying the word 3 first, you know that the subtraction is in the opposite order. So in this case, it's that same thing. Here's that sneaky word, watch out. It's asking you to subtract 3 from negative 26. So the negative 26 is in the front, and then you minus the 3. So you actually have minus 29. If you owed $26 and borrowed another 3, you would now owe $29. So now we're going to ease into algebra. I know it always seems a little intimidating when some letters start appearing in your math homework, but remember that the letters are just a number that you don't know yet. So to kind of ease us into that, they say, here's a letter, but don't be scared, it's just this number. So I'm going to replace the letter X with the number that they told me, negative 2. So I just rewrite this same exact statement as negative 2 minus 5. Now they told me that the answer should be 8. This is a true or false question. That's not true, because that would give me a negative 7. That is not equal to 8. So this would be a false. That one is not the answer. No, X is not equal to negative 2. So let's try this one. They said in this statement, my Y value should be negative 7. So I'm just going to replace that symbol Y with a -7. So here's that same plus a minus, so we know that's really just a minus. Is 5 minus 7 equal to -2? Sure enough it is. 5 minus 7 is -2. So the answer to this is yes. That would be the correct solution to this tiny algebra problem here. Next, let's look at some word problems. I know those are always everyone's favorite thing. Just kidding. The first step in any word problem is don't panic. Okay, don't shut down. You can do this. In fact, a lot of times the word problems are the easiest problems in the whole set because they know that you're going to get caught up in the words. So the actual work itself, the math, is going to be easy. So just take a deep breath, don't panic, read through it, and remember that the word problems are going to be just like the problems you were just doing. So since we were dealing with negatives, I don't expect to be doing, a bunch of multiplication with exponents or something crazy. It's not going to be anything weird. It's going to be these same plus and minuses. And sure enough, this one, it says that at noon the temperature was 77, but by midnight it had fallen to 55. So what was the change? So it went from 77 to 55. So be careful. It's now 55. 55 minus 77 is -22. Now, even if you didn't think to do the subtraction in this order, you knew it from this word that it was negative. You knew it from experience that this temperature is lower. The temperature went down 22 degrees. Next, we've got a missile fired from a submarine. Now, this one's a little funny because we've got the ocean here and a submarine down under the ocean. So here's my super awesome submarine drawing. It goes 470 feet up to the surface of the water, and then it goes up an additional 11,500 feet. I don't know much about it, but that seems pretty high to me. So it says, what was the total change in altitude? How far did that missile travel? So you have to be careful because it traveled up to the surface of the water and then some more into the air. So I need to not subtract. It seems like we should subtract because we're finding the change in height, but we need to add. And technically we are subtracting. It's just that this was the depth. So it went down to a negative value of 470 because he was under the ocean. So that's why I need to add these two numbers. So how far did that missile travel? That would be 11,970. That's a lot of feet. All right, and then the elevator. This one's fun. So you could kind of draw it out. You could write it in symbols, whatever works best for you. If they started on the 11th floor, went up 2 floors, up another 6 floors, down 4 floors, they're all over the place, 1, 2, 3, 4, and then down another 5 floors, where did they end up? So that would be, I've lost my place in there, so that's a little hard, but let's write it out in symbols. 11, up 2, up 6, down 4, and then down 5. Where did they end up? So we said that this one was going to be 13, then plus 6 put us on the 19th floor, and then back down 4 left us on the 15th floor, minus 5 would leave us on the 10th floor after all of that riding in the elevator. Okay, so after we got through it, when we didn't panic, those problems weren't as bad as they seemed. They never are. Those word problems are usually the easiest. Okay, so we have a few rules that we always have to keep in mind. So to keep things in the real number system, the 2 rules are that we cannot square root a negative, and we can never, no matter what, ever divide by 0. That's the one rule in math you can never break. There's always a little disclaimer on weird problems that you can't break that rule. So we'll just keep an eye out for those 2 rules there. We can't square root a negative or divide by 0. So when we're looking at some division, we can look at it with either the division sign that you've probably seen before, looks like this. You could see the slash like on the keyboard, but the slash on the keyboard really represents that division bar. So this right here, you may say is a fraction, but it's also the number 57 divided by 3. It all means the same thing. So whenever we're dealing with products and quotients, those are the fancy math words for multiply and divide. When we're looking at the signs, if they are the same, then the answer will be positive. So that means if you have a plus plus, it's going to be a plus. If you have a minus minus, it'll also be a plus. The answer will be positive. But if they are different, if you have one of each, positive times negative or negative times positive, either way, if you have one of each, the answer is negative. So that occurs with both products and quotients, both multiplication and division. So let's try out a few. So this one right here, I have 2 times a negative 7. Positive times negative is negative. 2 times 7 is 14. This one, I've got 3 numbers, but it's okay. Let's just take it 2 at a time. We don't have a rule for 3 because we just take it 2 at a time. So 3 times negative 4 would be negative 12. And then that negative 12 times the positive 2 would be negative 24. Next, I've got decimals, but don't panic, you can use your calculator. Even if you're using the calculator, keep these rules in mind. It's such an easy rule. Don't mess up by typing an easy rule into your calculator. So you know that these same signs, negative times negative, give us a positive result. And then let's just use the calculator for the numbers. So I type in just 7.6 times 9.3. Don't try to mess with the signs. All I really need the calculator for is the number 70.68. Okay, so same with division. Same signs is positive, opposite signs is negative. So in this one I have a positive 48 divided by a negative 4. Opposite signs, my answer is negative. So again, if you don't know the numbers, just type the number part in your calculator, but don't mess with the sign. Do that in your head. So if you type in 48 divided by 4, if you need to, it shows you the answer is 12. The final answer is negative because I had one of each. This one's negative divided by negative, so I know the answer is going to be positive. But if I type those numbers in, if I wasn't sure, I see that it's a positive 19. This one, again, I've got one of each, so it's going to be a negative. 42 divided by 3 is 14. Then we've got some decimals. Things are getting tricky, but we've got our calculator. But without the calculator, I know the rule says this will be positive. Don't bother typing in the signs. You're just going to risk making a mistake. Just type in the numbers and know in your human brain that the answer is positive. This one's going to be a negative because I have one of each, a positive and a negative, but I just typed the number part there into the calculator, 92.4 divided by 8.4 to get 11. Surprisingly pretty number. Here's another multiply. It's decimals, but we got this. So again, I know in my human brain that the result is going to be a negative, but I can use my calculator to help me out with those decimals. Negative 9.89. Here's some really crazy looking decimals, but they're both positive, so it's going to be positive. 49.53 times 0.43. Oh, it's long. Here's another one. Don't round it unless they tell you to. Type the whole thing. 2979. Don't write 21.3. You'll be counted wrong. Just write those last 3 numbers. And last, here's another division. Now be careful. You want to type it in the way the calculator understands. This is the number 85.65 being divided into 1.5s. So I type in the inside 85.65 first, and then I hit divided by 1.5 to get the answer of positive 57.1. Now we talked about how 0 is neither positive nor negative. He doesn't apply to these rules because the zeros are special. Anything times 0 will always give you the answer of 0. So 9 times 0, 0, that 0 times 4 is 0. Now 0 on the top is fine. In fact, if you type this into your calculator just to double check, 0 divided by 7, it tells you the answer is 0. But if you type this one in, you do 14 divided by 0, and then you hit enter, but don't do it. It explodes. Just kidding. But it does give you the error. So it says that you can't do that. You cannot divide by 0. It creates a black hole and destroys the universe. this answer does not exist. It's undefined. And it makes sense if you think about it. If you had 0 cookies for 7 children, each child gets exactly 0 cookies. So sad children, but no big deal. But if I have 14 cookies and no one to divide them among, no one to give them to, it creates a black hole and destroys the universe. So these have the answer of 0. This one does not have an answer. The answer is undefined. That is different than the number 0. So 0 is the absence of something. This one is nothing. Okay, so just remember, underneath is undefined. 0 on the bottom is the bad one. Underneath is undefined. Oops. Okay, here's a few more just to double check our knowledge. Here's some more fractions. But this one, when you type it in, you do get a decimal. But luckily in our TI 83 or 84, it can reduce the fractions for you. So clear out that error message and type in just like this, 3 divided by 33. Don't put those signs in because you know this. You know that it's going to be a negative. Positive or negative divided by positive is negative. So you get that crazy looking decimal, but here's our trick. We're going to use the math button just right here on the far left. And the very first option is fraction. So I hit the enter button twice, and it changes that decimal back into the reduced fraction for me of 1/11. Now you might be thinking, oh, that negative needs to be on top. Well, actually these 3 fractions would all be considered exactly the same. So if I put the negative on the top or the bottom or beside, they all have the same value because we know that the positive divided by negative is negative overall. So whether it's on top, bottom, or beside, it's always the same. Now this one you can probably guess. Negative divided by positive is negative, but anything divided by itself is 1. This one here, if you type it in, you do get the decimal, but then if you hit that math, enter, enter, it will show you the reduced form. Remember that it will be negative. Negative divided by positive is negative, but then it will show you the 4/3. Both the top and bottom were divisible by 3. 12 divided by 3 was 4. 9 divided by 3 was 3. So it just reduced it for us by canceling that common factor. And last, one more time, it is still negative. This one would reduce to 2/5. Both the top and bottom are divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And that's what the calculator is doing for you. Now, sometimes we need to unreduce things when we're dealing with addition and subtraction of fractions. So in this one, if I needed my denominator to be a 60 instead of a 10, I would need to unreduce it. So I'd say, oh, well, to get 10 to 60, I'd have to multiply by 6. But you can't just magically change things in math. You have to balance it. So if I'm multiplying the bottom by 6, I also need to multiply the top by 6. So this one would give me the unreduced fraction of 18/60. In fact, if you typed 18/60 into your calculator and hit your math enter, it would reduce the fraction for you back to 3/10. So we're unreducing it. Same story here. If I needed to get from 4 to 72, I don't know that one off the top of my head, but let's type it in the other way and say 72 divided by 4. Let's see what I need. If I wanted to multiply by something, the opposite of multiply is divide. So it shows me that I would need to go up by a multiple of 18. 18 times 4 is 72. 72 divided by 4 is 18. Same thing to the top and bottom. So if I take that times 3, I see that this would be the unreduced fraction of 54/72. I can then double check that by doing the math enter to see that it comes to the reduced fraction of 3/4. We're making good progress, so if you'll stick with me, we have a few more fraction rules here. So if we are dealing with multiplication or division, remember that the word of in any word problem almost always implies multiplication. So if I want to multiply, I multiply the fractions as is, so tops to tops, bottom to bottom. Now you might have heard this, you know, cross and multiply, and I don't know why that sticks in people's brains more than any other math thing, but cross and multiply is for solving proportions. You do not cross and multiply, we just multiply. So I say 4 times 6 is 24, 7 times 11 is 77. I just multiply. Okay, you can double check if it'll reduce with your calculator, but that should be it. Now in this one I have a divide, and my catchphrase for dividing is copy dot flip. Now I know that sounds weird, but we're going to look at it. The rule for dividing fractions is to multiply by the reciprocal. So when I say copy dot flip, it's just a silly thing to help us remember that the first one is going to stay the same, copy, not magically change. And then we multiply, so I use the dot for multiplication, by the reciprocal, which is the fancy math word for the flipped over fraction. So when I'm dividing the second fraction, I multiply by the reciprocal. And then I can start going through. Now I could multiply across and do just like I did here. I could use my calculator since these numbers get kind of big. But again, leave off the signs, you know this. Negative times positive is negative. Don't get yourself confused. Use your human brain. And then type in 54 divided by 7 times 8 divided by 45. You can type it in just like that. You don't have to use your little fraction buttons, just like that. It of course gives you a decimal, but when you math enter, it gives you the final reduced answer of 48 over 35. So just do those signs, the plus and minus in your human brain. Copy dot flip. Here's another one, let's copy dot flip. So 8 over 11 stays the same, and then I multiply by 7 over negative 11. We already know that we're going to get a negative result, and then type it in just like that, 8 over 11 times 7 over 11. Leave this sign off, you've already got that, and you would get that it's 56 over 121. Now, we're gonna do this copy dot flip every time, even when there's a whole number, but you might say flip what? How is it gonna flip? Remember that any whole number is understood to be over 1. So if I told you I had 6 of something, well that's 6 wholes, 6 of those 1 whole things. So now I can see where my flip is gonna come in. 5/7 times, and I would flip that over to 1 over negative 6. Lots of negatives in this section. That'll give us a negative answer 2. And then I would multiply to get 5 over 42. You can use that calculator. Next, we have 3 fractions. These are multiply, that's just a regular multiply. If you want to, you could get that answer first and then divide, or we could go ahead and do our copy dot flip. But the only one that's gonna flip is the one right after the divide sign. So these two stay put, no flipping. Copy dot flip. You only flip the one right after the divide sign, right there. Oops, I didn't flip them. So that would be 6 over 7. Okay, now I could type this in, but if you've done this before, you may notice that we have some matching ones. We could go through and kind of reduce things just to make our life a little bit easier. And then we can see what's left. If you're really good at reducing, we could even reduce these down. That would be 2 and 1. To see this final answer after typing it into our calculator is going to be negative. Again, these were all negatives, weren't they? 10, oh no, hang on. It would reduce again. 5 over 4. Okay, now it's the adding and subtracting fractions that gets a little sneaky. All of those were just straightforward, we could do it. Adding and subtracting, remember that you have to have that common denominator to get them to go together. But luckily you've got your handy dandy calculator, so you can just type it straight in. So on this one, you could type it in 11 divided by 15 plus 2 over 15. And you type it in just like that. You don't even have to worry about finding the little fraction button. So when you do that, it's going to do the decimal. But then when you hit math, enter, it gives you the reduced fraction of 13/15. These already have the common denominator, so you really could have done that one in your head. This one too, you could probably do in your head. They have the common denominator of 19, so I just say 5 minus 3 would give me 2/19. But if you're unsure, just not as confident, just type it in. You got this. Now, these do not have the common denominator, so I would recommend doing this in the calculator. You would type in 3 divided by 10 plus 2 divided by 12. It gives you the decimal, but math enter gives you the reduced common denominator answer of 7/15. It does everything for you. Use that calculator, because this is not our goal. It's not to try to teach you all these basics that you've learned before. We're trying to put these pieces together for a bigger picture. Now, luckily, this one's already got the common denominators, so I can really just look at the numerators. 7 minus 6 is 1. 1 minus 5, be careful. Now, I've overdrawn by 4. Now, if you weren't confident in that, type it in. 7 divided by 19 minus 6 divided by 19 minus 5 divided by 19. Math enter, and there you go. Here's some more of everybody's favorite word problems, but we got this. Okay, since I've been dealing with multiplying and dividing, I expected to be multiplying and dividing. First step, I'm not panicking, we got this. It says in a class of 90 students, 6 received a grade of A. What fraction of the class did not receive an A? Be careful, they're being sneaky there. Always watch that wording. Well, if 6 did, how many did not? We could do this in a couple different ways, but I would think, oh, let's see how many made not A's. Now it'd be 84. So it says what fraction did not? Remember, fractions are always the part over the whole. So those 84 did not out of 90, and it does want us to reduce. So if we type that in and do math enter, we get our reduced fraction of 14/15. Okay. Now this one's also sneaky. It gives you the fraction of this trip that is uphill. It says we're going 270 miles, this much is uphill, but then it asks us how much was not uphill. I know you're probably thinking, why didn't they just say downhill? But it might have been level. So they're saying everything that's not uphill. Okay, so if 4/15 is uphill, let's see how many miles were uphill. So I want to know what is 4/15 of 270. And remember, the word of really means I'm going to be doing a multiplication. So this is going to give me the uphill amount. So when I multiply in my calculator, let's see what we get. I get 72 miles of that trip were uphill. But be careful, we're not done, because they wanted to know what was not uphill. Well, if it was a 270-mile trip and 72 miles were uphill, what's left would be the downhill. So I would subtract, and I would see that the other 198 miles must have been not uphill, meaning either level or downhill. Okay, here's another one. We've got an airplane with 180 passengers. Hopefully they're all wearing their masks. They've got 5/6 of the plane full. Now this one's sneaky, okay? Let's draw it out. Here's our people on the airplane. Here's my super awesomely drawn airplane. Really tiny wings. Okay, so if I divide this cabin into 6. Okay, so not counting the tail and where the pilot sit. There's 6 sections for the passengers. It says that 5/6 are full. Now I'm sure they're spread out, but let's just simplify it. Okay, so here's all our passengers. We squished them all into the front. Okay, it says that there's 180 passengers sitting there in those blue spots. And then it says how many could have fit. So if these 5 slivers carried 180 passengers, how much would have been in each sliver? Let's see. 180 divided by 5 would make 36. Each one of those slivers would have been 36 people. Well, that means that last sliver that I didn't fill up must have been another 36 people. So that means 180 and 36 more people would have given me 216 total capacity of the airplane. So that's just kind of a way to reason through it. Now what they were really hoping for you to do is to say 180 divided by the 5/6 capacity. And when we do that, we do our copy dot flip, which does just like we did right here. So I did the divide by 5 like I figured down here. And then what I did is I took that times 6, because there's the 5 and 36 more, made it times 6. You can see that in a word problem, if you're getting stuck, you're not limited to one way. Just keep trying, think through it. Maybe there's another way you can find the answer. Okay, in our last little bit here, we're going to talk some more about some words, some mathanese, but again, it's not super important that you know the words as much as the idea. So a few of the properties that we use are the fact that the numbers can be switched, the order can be reversed in both addition and multiplication. They call that the commutative property. It changes the order. So notice in this one I have A and then B. On the other side I have B and then A. So both of these addition problems give me the same answer of 9. That works for both addition and multiplication. Not subtraction and division. The order is more important there. But the order can be flipped in addition and multiplication and get the same exact answer. The association affects the grouping, just like you have associates. Okay, it affects your grouping. Commutative is the order. Think of your commute back and forth to work. Whether you're driving from here to Little Rock or Little Rock back, it's the same trip. Okay, now this one, notice my ABC stays ABC. It does not affect the order. ABC both times. It affects the grouping. On this one, my A and B are grouped together in parentheses. This one, my B and C are grouped together. It says that in this problem, even if you added these first and then that one, you would get the same exact answer as if you added these first and then that one. And again, it works for both addition and multiplication. The identity property, just think about your identity. You never want your identity stolen. It's who you are, it stays the same. So if I wanted the number to stay the same even though I was adding something, the only thing I could do is the special magical number 0. A plus 0 stays the exact same number that you started with. In multiplication, the only way to do that is with the magical number 1. 1 is the one that keeps it the same. Anything times 1 is itself. So those are the identities, unchanging. The inverse is, think reverse, cancel. So if I wanted to get back to that magical number 0 and 1, the opposite of addition is subtraction. I would add its opposite and it would cancel out. The opposite of multiplication is division, shown here as a fraction. So if I divided by the same number, it would cancel back out to the 1. So inverse, reverse. And then last, a very important law that we use a whole lot later on is called the zero factor law. It might seem obvious, but it's the law that says that anything times 0 is 0, whether it's a 5 or a 5 billion. Anything times 0 is 0. And then last, the distributive property. He's pretty distinct. It says that if you have all of the numbers involved, you would follow order of operations, which we'll retouch in just a second, and do your parentheses first and then the multiplication. But sometimes that's not going to be possible, like when you have a variable in place like this. In that case, you would distribute the multiplication over the addition. Since I couldn't add these first, I would just multiply both of the members by that same 3. And that's known as the distributive law. Okay, so let's go through and try to identify some of these properties that were shown. This one I went from 8 to 4 to 4 to 8. The order changed, so this one was a commutative. This one I've got this big messy thing and this big messy thing that canceled out to be a 0. So this one was my inverse property. This one I started with a big messy thing, and ended up with the same big messy thing. They added 0. This was the identity property. Now this one, it looks sneaky. It's pretty distinct. I had a big messy thing, and I still have a big messy thing. It's not the same. It's not the identity. It did change. It wasn't the order changing. It was the fact that they distributed this 6. So it's one of the few properties where we have different numbers. It's not the same thing on both sides. Okay, and then the last one here, notice I have the same letters and numbers. 6, 4, 5. 6, 4, 5. The order did not change. One of their favorite things is to throw parentheses in, but switch the order and trick you into saying grouping when it was really commutative. So watch out for that. So in this one, the order is the same down here, but what they did is they regrouped it. So this one, the 4 and 5 are together. This one, the 6 and 4 are together. So this one is the associative. Okay. So with that quick refresher on order of operations, I always tweak. You've probably heard this, please excuse my dear Aunt Sally, but I tweak it just a little because P stands for parentheses, which is not all that you need. So when it says parentheses, it's really a form of grouping. So I use a G for grouping. Now parentheses are of course the most common, but some other options you might, in fact we saw in one of them, see the square brackets. Those are just a visual, form to try to help you distinguish which set is being grouped. You might also see curly brackets. You might see things grouped inside of a square root. You might see things grouped into an absolute value, which we'll talk about later. Or you might see things grouped on the top and bottom of a fraction. So it's any of these different forms of grouping, not just parentheses. Next, the E for exponents. That's pretty straightforward, no tricks there. Next, the my dear and the Aunt Sally. So whenever it's written in this way, it implies that multiplication happens first, but really it's multiplication and division at the same time as you work from left to right. And then you do addition and subtraction as you work from left to right in the same order. So that's why you see those problems on Facebook trying to trick people into getting the wrong answer on a problem like this, because people tend to think that we need to multiply before we divide because of this acronym. But really, I do multiplication and division as I work from left to right. So in this problem, I would really take 36 divided by 2, which gives me 18, and then multiply by 6. So 18 times 6 would give me the final answer of 108. So now you can go and impress all your friends on Facebook. Okay, so this one, it's not that I divide before I multiply, it's left to right. So this one I would go 12 times 3 because that's the first one, left to right, and then divide by 4. Okay. So another reason that I don't like the P for parentheses is because it makes it sound like all parentheses should be done first. And in a problem like this, the parentheses are not grouping something. This one is just holding a 2. It's a different form of showing multiplication. It's saying 4 times the negative 2, just like we saw when we were learning about the signs. So there's nothing to do in this parenthesis. He's not first. Instead, the first step of this problem would be the exponents. And in these longer problems, and they start to get pretty long, so they're trying to trick you. I highly recommend write out every single step until you get there. Don't try to do little arrows and things and point and change. Write it out. So I copied everything else down except for I'm going to do this one step where the exponent 4 squared is 16. Remember, it's not 8. It's 4 times 4 twice 16. Next, I go through and do the multiplication from left to right. So here's my first one, 8 times 2 is 16. 4 times negative 2 is negative 8. And then last I go through and do my subtraction from left to right. 16 minus 8 is 8, but then that 8 minus another 16 is negative 8. So take that time. It takes like 2 lines of paper, 5 extra seconds. Write it down. Don't try to skip steps and point and arrows. You will mess up. It happens. We're human. Now this problem does have the grouping parentheses. You can see the difference. There's stuff to do inside of them. They're around operations. This one was just a single number. So within this grouping, there's another order of operations where I do exponents before subtraction. So I would say that would be 2 squared is 4. Next, I would, to finish off the grouping, I would subtract, and 4 minus 5 makes a -1. And last, I work multiplication and division from left to right. 9 times 3 is 27. And then 27 divided by -1 would be -27. And this one right here, again, I have stuff to do inside. Now it's fractions, so if I needed to, I could pull out my calculator, but I don't recommend typing in the whole big thing. Type in one step. So in my calculator, I'm gonna type only 1/3 plus 1/10. Just that one step, and I'm gonna write down my steps as I go. So if you try to type in the whole thing, you're gonna mistype something. These get really big. And that's gonna give me I do my math enter of 13 over 30. Here's that copy dot flip. All my rules coming together here. The grand finale. And then I can type it into the calculator. Remember, do the sign in your head. Negative times positive is going to be negative. I only type in the 15 times 30 over 13. I'm going to do my math, enter. It's a really big one, but it's going to be 450 over 13. Okay, here's another one. Here's those cleanup parentheses. See, there's nothing to do. It's just a single number. It's just keeping the negatives cleaned up for me. So looking through, there's actually no groupings. There's no exponents, so I just start in on multiplication and division from left to right. So it's all multiplications and divisions. So I'm just going to go left to right. 14 times 3 is 42. And then 42 divided by -2 would make 21. Sorry, -21. Positive divided by negative. And then over here, this is another multiplication, 6 times 4. So I need to do that multiplication before the subtraction. That would give me 24. So finally, I have -21 minus 24, which makes -45. Okay, and then last, again, they're trying to kind of ease us into the algebra. So they gave us some scary letters, but then told us what they are. So they said the x is really just a 2. The y is really just a 0. So we're going to go put those in. So this would be 5 times 2 plus 2 times 0 plus 2. So 5 times 2, 2 times 0 plus 2. So 5 times 2 is 10. 2 times 0 is 0. Everything times 0 is 0. 10 plus 0 is 10. Plus 2 is 12. Almost there, guys. Last slide. So we kind of talked a little bit about some of these words here. We mentioned product and quotient already. So here's a handful of words that can all mean addition, add, sum, plus, more than, increased by, things like that. Subtraction, remember I said those words to watch out for. From and than. Those are the sneaky ones that make things backwards. So it's not the less. You can say less and not be backwards. It's only less than. Okay? So watch out for those. Product is multiplication. It's slightly less common of a word. Remember, of always means multiply. And then quotient is a division word. So it's not one you hear every day. So that one means division. So let's see if we can interpret some of these. The quotient of y and 5. That means we're going to take the y divided by the 5. I could write it like this, or I could write it in that fraction form. Both are acceptable. This one is actually a little bit preferred as you get higher in math. because this would be easy to make it look like a minus sign or get confused, but this is more clear. So this is the preferred. 7 less than a number. Here's that backwards. So if I wanted some mystery number, I could use any letter. X is, of course, our most common. So 7 less than, backwards, 7 in the back. Now this one's sneaky, 3 times the difference between a number and 8. So when it says 3 times the difference, it's not saying 3 times the number. It's implying that the difference of the number and 8 needs to happen first. You need to do the number minus 8, get that answer, and then multiply by 3. 3 times the difference, not 3 times the number. A number decreased by 13. No from or than, so it's just number down 13. 8 minus twice a number. 8 minus twice a number. That would be 2 times the number. Oops, I think I missed some up here. I did, oh no, I'll have to come back to those. Forget to scroll down. Okay, 14 more than 3 times a number. More than is a plus, 3 times the number. 5 less than, there's that sneaky one. That means the 5's actually going to be in the back. 5 less than, reverse the order. 3 times the number. 9 more than twice the sum of 17 and a number. 9 more than twice the sum, just like that one, twice the difference. That means the sum needs to happen first. 17 and a number doubled. 9 more than twice the sum of 17 and a number. Okay, now these last ones, evaluating in English phrases, you could do a few different ways, so you can kind of play with those. You could say something as simple as 10 minus a number, 5 times a number plus 3 times a number, or the sum of 5 times a number and 3 times a number. This one you could say like we did up here, twice the difference of a number and 3. So remember to indicate that that needs to happen first, not just twice the number, twice the difference. Okay, and then real quick, I missed these right here. Let's go finish those up. Here's the fractions. So they look scary, but we got this. So just remember to do a little bit at a time. Don't try to type the whole thing in your calculator. These are cleanup parentheses. It's just holding this one fraction. So I'm going to keep that one fraction together there. Here's my first step of multiplication. So I'm going to multiply just these two in my calculator. 3/8 times 4/5. And then when I do my math inner, I get 3/10. And I'm going to rewrite everything else step at a time. Okay, next I would do my division. There's that copy dot flip. I'm going to rewrite everything else step at a time. So it's going to copy dot flip. It only flips this guy right after the division. It didn't affect the 2/3. Now I can do that fraction in my calculator. So I could go 3/10 times 5/2. And then your math enter to see that's the fraction of 3/4, which makes the rest of this problem pretty nice. Because if I have negative 3/4 plus 3/4, they would cancel out. So the final answer ends up just being that last fraction there, 2/3. And then one more of those scary ones. They're trying to scare you, but you got this. This x is going to become a -2. This y is going to become a -7. And this z is going to become a +4. Let's write it out. So I've got -5. I'm going to put them in parentheses, some of those cleanup parentheses, plus I'm going to put some more cleanup parentheses around the y, just keeping everything nice and pretty, -2, and z was a 4. Okay, so my order of operations, here's some of that grouping on the fraction like we talked about. On the top is a group, so I'm going to clean up just the top. Here's a multiply before the add. Negative times negative is +10. And then +10 plus -7 is really just 10 minus 7. and then 10 minus 7 is 3. So just looking at the top, I know the top is going to be 3. On the bottom is a multiply. Positive times negative is negative. So my final answer is that positive 3 over negative 8. Negative 3/8. Okay. That should be everything. I think we got it. Sure, real quick, I didn't forget to scroll on anymore. No. And if you ever have questions, make sure to come and see me. I am happy to work through any questions. You can always email me. We will get it worked out. And that is all of chapter 1. So like I said, it's a little bit scattered, but you can go through. If you get stuck on something, move on, come back to it. It might make more sense after you've done something else. Okay, have a great day.